Well, hello there. My name is Figa and welcome to MV Tutors. Now, if you would like a tutorial session after this, please make sure to visit our website www.mvtutors.co.za, or alternatively just comment under this video and ask for one. So today we are doing my favorite topic in mathematics, Euclidean geometry, as you can see from this past question paper. Yes, I like to start my sessions with a vision in mind. Yes, and what is a vision, I hear you asking? It's just basically a past paper that we are working towards. So what we do is that we set the vision that this is what we're trying to work towards, this question, and then we can go back and do the theory associated with it and get all the principles that we need to answer these types of questions. And then towards the end, we will actually do this question. So if you look at this question and then you see that there is something you don't understand in it, well, you're at the right place. Stick around, and by the end of this session, you will be confident. Right, now when it comes to Euclidean, there is actually an acronym that should help you to remember everything. It's basically called Dr. Cape Town. Okay, it's very popular, most people use it, but let's just go ahead and write it. So doctor is just DR, that's doctor. And then Cape Town, you also write the acronym of Cape Town. Well, I don't know if whether to call it an acronym, but yeah, let's just call it an acronym. It's CPT. CPT stands for Cape Town. All right, so it's Dr. Cape Town. Now, let's go on and explore what each one of them actually means. Cool, so let's start with the D. All right, let's start with the D. D stands for diameter. So that means that we are dealing with the theorem which involves a diameter. Now, if you have a circle, okay, and you have a diameter, let's say there, over there, we've got our diameter. Now, the theorem is that the angle which the diameter subtends is always going to be 90 degrees. Now, it doesn't matter where the angle is subtended. It can be there, it's still going to be 90. It can be there, it's still going to be 90. The fact that it's from the diameter means that it's going to subtend a 90-degree angle. Now, what's the reasoning for that? How do you write the reasoning? You just say angle on diameter. That's the only theorem you have to remember concerning a diameter. Now, the next letter in the acronym is R. And like I said, R stands for radius. Well, I haven't said it. It's my first time saying it. But it stands for radius. Now, what's the theorem concerning a radius? Now, let's say we have a circle once again. We have a center there. And then that's a radius. And you have another radius there. Now, if you have from the same chord, okay, there is a theorem that says this angle here, okay, and that angle there, the angle at the center versus the angle at the circumference, the relationship is such that if that's x at the angle is x at the circumference, then the angle at the center is 2x. It's twice, it's double the angle at the circumference. Now, this one, we call it, just the reasoning is angle at center. Okay, now the angle at center theorem says the angle at the center is twice the angle at the circumference. Now, coupled with that, okay, now the very same fact that it's from the same chord, it doesn't matter where you subtend the angle, it's still gonna be x. Okay, so that angle is equals to that angle, or even if it comes on this side, that angle is still gonna be x. So all angles are the same because they're subtended from the same segment. So that reasoning, you just say same segment or same chord. It's up to you. You can use the word segment or chord. It's the same thing. The fact that they're from the same chord means that the angles they subtend are also the same. Now, let me just also add this one in. It's the same theorem. If you have two chords that are like that, and these chords are equal, okay, the angles that they subtend, okay, they are also equal. Okay, the angles subtended by the equal chords. Okay, so even this one, same theorem. Okay, same chords, same angles. That's the theorem we're dealing with now. Now you must remember this one is very important, and it falls under radius because the angle at the center is subtended by radii. So that's a radius. That's a radius. Okay. Okay, now let's talk about the next letter in the acronym, which is basically C, and it stands for cyclic quad. Cyclic quad. The quad is quadrilateral. Okay. So what are the theorems of a cyclic quad? There's basically just two of them. The first one is that if you have a circle and you have a cyclic quad. Now, what's a cyclic quad? It's actually a quadrilateral that is inside a circle. So all the points of it, they touch the circle. That makes it a cyclic quad. The first theorem that you must know is that if I extend one of the lengths, one of the sides of the cyclic quad, then the theorem states that the external angle is actually equal to the internal opposite right there. Okay? The external angle is equals to the internal opposite. All right, so how do we write this one? So it's external angle of cyclic quad. That's the reasoning. So that's how you would write the reasoning. Now, also, the other thing that you must know about this is that if I have the same circle and the same cyclic quad, doesn't really have to be the same one, but as long as it's a cyclic quad, then the opposite angles, okay, so that angle and that one, they have a relationship. They are not equal. I repeat, they are not equal, but they are supplementary. So opposite angles of cyclic quad, okay, are supplementary. What does supplementary mean? It means they add up to 180. Okay, so they add up to 180. So if one angle was 80 degrees, then the other one is 100 degrees. That's it. Remember that. So these two laws are actually connected, because then you can prove that if you extend this line, then this is a straight line. If these are if the opposite angles are supplementary, then the external angle surely must be equal to the internal opposite, because as you know, a straight line also adds up to 180 degrees. All right, so for example, if this was 80 degrees, then this is 100 degrees. Okay, and because a straight line has 180 degrees, I say 180 minus 100, it gives me 80. So that's 80. So that's where then you get this external angle of a cyclic quad, where this angle, the external angle, is equals to the internal opposite angle. That's it. Remember this. Right, so now let's talk about the next letter in the acronym, Dr. Cape Town. So we've dealt with the C, now we're coming to the P. The P stands for parallel. So this is parallel lines. Now, parallel lines has its own acronym. It's just fun. Parallel lines are fun. So like that. Fun. Okay, so what does this mean? Right, first of all, in identifying your parallel lines, let me use a highlighter, change the color to yellow. These are the parallel lines over here on F. Okay, and then on U, these are the parallel lines over here. And then on N, these are the parallel lines. Cool. Now let's go back to identifying the angles in these parallel lines. Now, under the armpits of the F, there are the armpits. I'm calling them the armpits, but they actually are armpits. Under the armpits of the F of parallel lines, that's where you get what we call corresponding angles. Okay, that means the angles are equal. Okay, and the reasoning is that they are corresponding angles. Now, whenever you mention parallel lines, whenever you mention that they are corresponding angles, you need to mention what are those parallel lines actually. You need to name them. And then under U, also in U, we look at the angles at the armpits. Okay, now these angles are not equal, but they are supplementary, meaning that if you add them up, they equal 180. So we call this one co-interior rule, where the angles are actually supplementary. Remember that. Don't say they are equal. They are not. They are supplementary. Okay. Now let's go to the N. Now, you also, likewise, you look at the armpits of the N. There we go. Right there and right there. Those are the armpits. These angles are equal, and we call this alternating angles. They are equal. All right. Remember this. You will need it. Okay, so the last letter on the acronym of Cape Town is the letter T, which actually stands for tangent. Now, the laws of the tangent, or the theorem, you have a circle and then you have a tangent. Now, the first one I want to deal with is the one that has to do with the radius. If you have a radius and a tangent, the relationship is always that they are not perpendicular, but they are, what do you call it when they make 90 degrees? What do you call that word? It's not perpendicular. It is perpendicular. It's not parallel. Sorry, I just had a memory lapse there, but that's fine. That's fine. Mistakes are permitted as long as you correct them. This law, this theorem is called the radius is perpendicular to the tangent. Okay, so the radius is perpendicular to the tangent. That's it. That's it. Now, it doesn't matter where the radius and tangents are. You can have the radius there and your tangent there. It's still going to be 90. You can have your radius there and your tangent there. It's still going to be 90 degrees, which is perpendicular. Now, the other law that has to do with a tangent is this one. Check this one out. If you have a circle and inside the circle you have a triangle touching all points of the circle, the circumference, and I have a tangent here. You need to pay attention to this one because it's about to get dicey. This one, first of all, it's called the tangent chord theorem. Okay, now it says that the angle between the tangent, which is down here, and the chord, now let's say we're dealing with this chord. So the angle between the tangent and the chord is equal to the angle opposite that particular chord. So the angle opposite this particular chord, the angle is touching, is this one. Okay, let's do it again. Let's make another example. Now let's say our tangent is gonna be up here. Okay, they touch there. The angle between the tangent, that's the tangent, and this chord, okay, is equals to the angle opposite that chord, which is also there. Okay, now let's do another one. Okay, now let's put it there. Let's put the tangent over there. The angle between the tangent and the chord, let's do this one. 1, 2, 3. That angle there is equals to the angle opposite that particular chord. So that's the chord we're dealing with. The angle opposite that particular chord is this angle. Remember that. Okay. Now, that was all the theory or the principles that you needed to answer this question. Let's try and apply what we've just learned to answer this particular question. So, it says in the diagram below, P, M, T, and R. Now, I encourage you to actually find these as you read. Where is P? P, I find it there. M is there. T, where's T? T is there, and R. Okay, it looks like they form a cyclic quad. Okay, points on a circle having center O. Now that's important. They tell us that we have a center. Now you have to start thinking of all the laws that affect the center. And the law that affects the center the most is basically that one, that the angle at the center is twice the angle at the circumference if they're coming from the same chord. All right, then PR is produced. Where is PR? Let's look for PR. PR is produced. That means it's made longer, it's extended, and meets MS at S. Where's MS? Okay, I see it. There's MS. Okay. Radii OM, so that's the radiuses, and OR, they have to be radii because we've been told they come from the center. O is a center. And radii OM, OR, and the chords MT and TR are drawn. Where's MT? mt and tr, okay, such that T1 is equals to 148, PMO, where's PMO? PMO is 18, okay, it's shown. And then S, the angle S is 43. Where is it? There. We've identified everything now. Okay, now let's go look at the actual question. It says calculate with reason the sizes of P. Okay, so where is P? Now, there is P over there. Okay, so what do we know about this? We do know that we have a cyclic quad over here. Okay, PM and then T there to R and then there. So that's our cyclic quad. Now, what do we know about the cyclic quad from Dr. Cape Town? We know that cyclic quad, the opposite angles are actually supplementary. So then we can go on and say, actually, P, angle P plus T1, they equal 180. And the reason is because they are supplementary or opposite angles of cyclic quad are supplementary. Okay, so that's how you reason it. Now, P is what we are actually looking for. T1, we already know it's been given as 148. That's equals to 180. Okay, so at this point, we would need a calculator to say 180 minus 148. Just hold that thought. Let me go get a calculator. All right, I got my calculator now, so let's just grab it over there. And what we actually want to do is say 180, struggling to write an 8. I mean, how hard can that be? 180 minus 148, put that in a calculator exactly as it is. And then we get 32. So that's equals to 32. So our P is equals to 32 degrees. That's it. Now, number 2, we need to solve the angle O1. Where is O1? Over there. Okay, but first let me rub this because we don't need it anymore. Now, O1. Okay, so from Dr. Cape Town, we know the relationship. They are from the same segment, okay, with P. Now, from that theorem we learned about the radius is that we know that this angle is 2 times x, if that one is x. Okay, so that one is x. Right, so what do we know about this? We know that P is actually x. When we've just solved it, it's 32. So we can then go and say O1 is actually equals to 2 times P. And what's the reason? Angle at center. Okay, angle at center. Now, let's go and solve it. 2 times P, we've solved it, is 32. Let's put that in a calculator. Okay, so we are just going to clear that. 2 times 32, we get 64. Right, so it's equals to 64 degrees. That's it. That's it. Okay, let's do number 3 now. Let's go check out number 3. Number 3 says OMS. Okay, so we need to rub this, and then let's get down with the OMS. First of all, we have to identify OMS. So it's O, M, and S. So that angle over there, that's the angle we are looking for. But what can we notice here? Okay, so we have a triangle there. If you look at this triangle, P, MP, and then PS, and then that triangle over there. Okay, do you see that we have angles? We can use the internal angles of a triangle. We know that the internal angles of a triangle, they add up to 180. So if we do that, we can probably solve that angle OMS. Okay, so but right now, let me just call that angle OMS M1. Okay, no, actually, let's leave it as OMS, yeah, for ease of calculation. So now we can say 43 plus P, remember we calculated it to be 32. Yes, we did. So we can then say 43 plus 32. Now I want you to see something else here. Do you see as part of M we have a little one there, that 18. Okay, so we need to add that 18, which let me just put it in brackets so that you can see that 18 is part of M. So I'll put 18 plus OMS. Okay, why did I do that? It's because they are both on part of M. The whole M is 18 plus OMS. Okay, so if I add up all of these, they should equals to 180, and the reason is angles of a triangle. Angles of a triangle always equals 180. Now then I can just say the angle OMS is equals to 180 minus 43 minus 32 minus 18. Okay, let's quickly put that in a calculator. Bring that baby up. Clear that. 180 minus 43 minus 32 minus 18. Okay, and then ladies and gentlemen, 87 is our answer. Okay, let's go on and do the last question, which is question 4. I just rubbed the things on the top there because I didn't need them. Okay, I rubbed what was irrelevant. So what is relevant here? Let's say R3 if TMS is equals to 6. So TMS is this angle here, this red angle. Okay, so they give us that angle, and what we are looking for is this angle R3 here. So what do we know? What can we say about that R3? If you notice the cyclic quad, let me just put the cyclic quad in there. That's our cyclic quad. You can clearly see that the theorem of the cyclic quad, the external angle theorem, says the external angle of a cyclic quad is equal to the internal opposite. So that's the internal, that's the opposite. So it's equals to that angle. Okay, that angle is actually angle PMT. Okay, so that's angle PMT. So then I can go then and make my statement here. First of all, I can say R3 is equal to PMT. Okay, and the reason is external angle of cyclic quad. There we go. Okay, so now all we need to do is solve the angle PMT. All right, let's go see. Let's go check it out. That angle PMT, we can solve it. We just solved angle OMS. So OMS, let me just demonstrate OMS using a different color. So OMS is this angle O, M, and then it goes down to S. Okay, or maybe let me do it a different way. Let me say OMS is this angle here. Good. So you see what we're gonna have to do now to solve the angle, to solve the blue angle. I have to say green. Okay, I have to say the green angle minus the red angle, and that's gonna give me, let me put a different color. Let's say purple. That's gonna give me the purple angle. Okay, so I have to say once again, just to demonstrate it, I have to say, first of all, I have to add I have to add 18. We are looking for the blue angle, right? So let me just put blue first. Say we're looking for blue. To get blue, blue is equals to green. All right, there we go. And then green, it's equals to green minus red, minus the red one, the red angle, and then that's gonna give us the purple, and then we have to add, then as a last resort, we're gonna have to add that 18. Okay, purple, yeah, purple is confusing you guys, so let's just work with green. And actually let me delete purple, because I can see it's going to cause a problem. It's already confusing me because I really don't need it. Okay, so we're saying blue is equals to green minus red plus 18. Hold on, let me just switch off my phone. Sorry about that. Sorry. Switch that off. Okay, we're back. So how do we get blue? So blue is basically the angle. Let me write it in blue. It's basically the angle PMT. Okay, and I'm saying that's equals to the green angle, which is, what's the green angle? The green angle is OMS minus the red angle, which is the red angle is TMS. Okay, and then plus 18. Okay, so let's add these up. What is OMS? Do I know what OMS is? OMS, we solved it here. Yeah. And we solved it to be 87. So that's 87 minus TMS. We are given it's 6, then plus 18. Okay, so let's put all of those in a calculator real quick. Oh, we already have 87, but let me clear it. 87 minus 6 plus 18. It's going to be equals to 99. So we can conclude then that if PMT is equals to 99, then the angle R3 is equals to 99 as well. Well, I hope that made sense to you, but in the case that it doesn't make sense, I would love to explain it to you further. So drop in that booking and I'll give you a one-to-one tutorial. Okay, bye bye now.